Hello, welcome to this short video in which I'm going to show you how to set up a lab in EVE-NG for testing any network, but for my purpose I'm setting up an environment to run some Ansible playbooks against. So a lot of videos that you see on YouTube end up showing you this topology or any topology, and then they dive straight into the automations, and a lot of people have said to me, can you show how to actually build the topology to start off with? So that's what we're going to do in this video. We're going to build this OSPF topology. We're going to build that manually, and then in the next video I'm going to build the configuration on here using Ansible. So this is what we're going to do. So we're going to close this lab down. So to give a bit of background, EVE-NG is an automation platform that you can simulate and run live images from any network vendor who has got a virtual image. It runs as a virtual machine, so I'm running my EVE-NG on an ESXi server, which is actually a PC with 16 gigs of RAM sat in my spare room, so nothing hugely glamorous, but it does the job. So this is the start page for EVE-NG, and I'm going to add a new lab, and we're just going to give it a name. So I'll call this one OSPF 2. And then you've got a blank canvas where you can add your network objects. Now EVE-NG comes without any devices installed. When you build EVE-NG, you have to upload the router images to them. I'm not going to go into that in this video, but if you want to see how that's done, and I'll drop a link in the description of another video where we actually upload the router image. For this I'm using Cisco CSRs, and when you go into EVE, any device of which you can see there are potentially a lot that you could use, any that have got that are highlighted a little bit blue here, these are the ones that I've actually already pushed an image into EVE that I can use. I'm just going to type CSR in here just to shortcut that, and I've got a CSR 1000V which I've loaded the image for, and it will ask you how many nodes you want to add. So for this topology I'm going to add 6, and we hit save, and then we've got 6 CSR routers that I can start to build my topology. Now for anyone that's used GNS3, this will look sort of very familiar, but the benefit I think with EVE-NG is that you can run so many different vendors. In fact, I haven't actually come across a vendor yet that I was unable to load into EVE-NG. So now we've got the 6 CSR routers. I am just going to arrange them into the topology layout that I wanted to do, and that looks like this. And then we need to join all the network interfaces together. Now you have to do that when the router is shut down. So when you drag the link between the two devices, EVE is going to come up with the interfaces that are available, and you can actually choose which interface you want to connect to which. So I will do 1-to-1 on here, and then this one we'll do 2-to-2, and that one 1-to-1, and then we'll put 2-to-2, one-to-one, and 2-to-2. So we've now connected the interfaces together between the devices, and if you don't like the way that the links have lined up, you can just wiggle the routers around a bit. It sort of automatically joins them to where it thinks it looks best, but if you want to make it look pretty, you can adjust it a bit. Now there we go. And then what I'd like to do is to add an object. We're going to do a custom shape. Pick a nice sort of blue color here. Something like that's a bit of a green actually. And we can then give this a little background. All very straightforward so far. And then I'm going to add an object, some text. We're going to just say this is going to be OSPF area 0. So that's what I'm going to do, and make that a 24-point font. Okay, so this is the basic layout. Now we'll start booting these in a minute, but at the moment these devices will live within the topology, and I could connect to each device via the console, but what I want to do is to be able to connect to these devices from my laptop. And to do that, you need to add a network, and in here we will select the management cloud. Now the management cloud is a bridge that sits and creates a virtual network card on your laptop, and then you can then connect from your laptop device into any of these networks and connect into your lab. So this is quite essential. And then again, we'll just drag these and connect up to each device. Now I always like on the CSRs to connect to gigabit 4 for the management interface. So we just drag these. You can see it's very straightforward. And 4. Five, and number 6. So once we have the management cloud connected, we've now got all the routers connected up, so I can ping through here and check out, and the management cloud is connected. Now you can do whatever you want with this. You can sit it where you like, put it over here. I like it up, we'll stick it at the top. You could even do this. Put that in the middle. I could put the... we'll do that. That looks pretty. Okay. So now we can start each router up. And then when you hit the device with the left mouse button, this will then open up your default terminal. For me, this is Secure CRT, so I'm just going to say yes to that. And this will now start to boot. Now the CSRs will take a couple minutes to boot up. So while that's booting, I'm going to go into another device that I've got. So I'm running an ESXi server, as I said, on the PC. That's just sat in the spare room running this, and then on my laptop I actually run Ubuntu, and that's for my network automation. And then we're going to be able to automate the configuration on these devices. Okay, so router 1 has just booted, but you see it's desperately trying to get a config off a TFTP server. So I'm just going to put on a configuration here, no service config. That will stop the router trying to go off and boot off a TFTP server. So that's router 1 now connected, but I'm connected to that router via the console. So this is a direct console, virtual console into this device here. We're not using any network, we're not using the management. This is a console into the device straight into EVE-NG. So what I'm going to do now is just start up all the other devices, and I'm just going to pause the video. We'll come back when all of these have booted. Okay, so the routers are just about booted up now. I've got router 1 online, router 2 is up. I need to put that config on. Router 3 is up, and we're still rating for 4, 5 and 6. So I'll go into some basic config that I have to get onto each router. So now that we've built the devices, there is a basic setup, and I'll show you what that looks like. So for the CSRs that I'm using, I have to put no service config on, and then I have to do a username, define an IP domain name, generate an SSH key, and then enable SSH on the VT wirelines. So that is the base config, and then on each device we have to put an IP address on that gigabit interface, gigabit 4, so we can actually connect to the device from outside. So I'm actually on my Ubuntu machine here, so this is technically outside of the network. This is an external device to EVE-NG. So I've just got that config. So for router 1, we're going to pop that on, and it's moaning that I need to put a host name other than router, so might as well do that as well. CSR so this will be CSR host name CSR-1. I can put that on. Okay, so now I've got basic username, enabled SSH, and given it a host name of CSR1. So this one we need to do the same thing, and then I'll show you this basically, and then in later videos we'll go through how to actually automate this in EVE and other options to build your topologies out a lot quicker. That's that one, CSR3. This one will be called CSR3. So how are we doing? So right, number 4 has come up now. Host name CSR4. So all I'm doing here is just pasting that config on, and I've already seen that there's an error here. So this is the problem with pasting config. That line there should be IP domain space name. Go back to the first device. So any automation that you do on devices, you need to verify the command that you're doing first. So let's just verify that. So it's IP domain name, not domain hash name. We'll do that again. I'm just going to paste these in. Now that's working better now. Okay, the CSR3. Now it's warning me that I'm doing a non-secure password, but this is just a lab, so I'm not too concerned about that. And CSR5 isn't up now. Host name CSR5. CSR-5, that's better. And hopefully CSR6 will be. This one's moaning, I didn't put that no service config on there. Okay, and CSR6 is up as well now. CSR6. So just to recap, I've got 6 CSR routers now, all running in EVE-NG. They've all booted. I've gone in and I've put a very basic configuration of a host name, and let's go back to my code. So a host name, and then we've put username Roger, priv15, password Cisco. You've got to create a domain name. So this is roger.local. I generated a crypto key, and on the VTY line, I said login local transport input SSH, which just allows us to SSH to those devices. So I'm still connected on the console, the virtual console from EVE-NG. And the final thing I have to do is give the Gigabit 4 interface an IP address. But before I do that, I'm just going to add some notations onto the diagram here so we can see what's going on. So this is going to be, so I'm going to put management network 192.168.1.0/24. So this is my network that I'm running. So that is management network is 192.168.1.0, and then on each of these Gigabit 4 interfaces. So I'm going to call this one, and the reason why I've used these will become apparent shortly. So that one is going to be .220. I'm just going to duplicate that. So I just right clicked. Just right click on the anything you like and it will duplicate it. So CSR2 going to be .221. Right click, duplicate again. This one will be 222. So the one key thing when you're building a lab is to have all the information available so you can see what you're doing, because it gets very confusing if things don't work. But if you can just look at your topology. So I'm not really a huge fan of making it massively pretty, but it just needs to have all the information in there that you need. So it needs to look reasonable. So this one's 224, and then this one will be 225. Okay. So I'm going to bring up a command prompt now. Okay. So if I ping 192.168.1.220, do a -T to keep the ping going, you can see that the request timed out. So oh, hello. Something's pinging. Wonder where that's coming from. Got a device already on 220 here. Let's just find out where that is a minute. Hold on. Well, that's very strange. I've found the device. Funnily enough, CSR1, which was the correct device, is actually picked up via DHCP the correct address, which was a bit of a shot in the dark. So I'm just going to go in and assign that statically now. 192.168.1.220. So let's just see what's happened over here. No IP interface brief brings up the that one's picked up 221, which is great. IP address 192.168.1.220. CSR3. No, that one's picked up a random address. So GI4 IP address 192.168.1.22, and then this is where I've forgotten. So it's a quick check on the topology. CSR3 is 222. 222. Now we've got a duplicate IP address, so someone else has got 222. So who had two? He has got 221. He's got 220. That one's got 225. That one's picked up 224. And I've seen there's the duplicate address. Gigabit CSR6 has picked up 222 as well. So GI4 IP address 192.168.1. So 6 was going to be 225. And save that. This one will be 224. One's actually got it via DHCP. And then this one needs to be 223. You can see if you have a duplicate address, the Cisco router, if it's on the same subnet, it'll start moaning about it. And this one is 222, which we fixed now. And that one is, yeah. So we're all good. So now, again, the position we're in, we've now configured all the devices. They've all got a management IP address on gigabit interface 4, but we haven't got any of the connectivity set up on these devices. So this is where I'm going to now go in and manually set all the IP addresses on each interface. So we're going to work around these one by one. So if I bring this up, I've lost it. There it goes. So that's not going to fit. So I thought I could do, let's just do it like this. Get rid of the session manager. And another thing you can do with Eve is you can select this entire lab, and I'm just going to pop it up there for a minute, and then I can bring my, okay. So I need to create some layer 3 point-to-point links between all these devices, and we are going to use what should we say? So this is the point-to-point links. We'll use the 10 network, 10.0.0.0/24. Now you can see this is quite a monotonous task. In the next video, you'll see how, with the power of network automation, this is super quick and easily defined. So the first one I'm going to do 10.0.0.1 and 2. So just show you how this works. So that one will be 10.0.0.1, and this one will be 10.0.0.2, and we'll give these a /30. So now we've got the visualization. I can go interface gigabit 1 IP address 10.0.0.1 255.255.255.252 and CSR 2 gigabit 1 IP address 10.0.0.2. Now I should be able to ping now 10.0.0.1. So I'm now pinging between these two links here, and that's not coming up. So let's have a look. IP interface brief, and this port is shut down, so interface GI1 no shut. Let's just check CSR1. Yeah, same. Okay. So now I should be able to ping. Yep. Interface gigabit has come up. There we go. So I can now ping 10.0.0.1. That's got me connectivity to here. And I'm also going to give each device a loop back. 1.1.1.1. So now if I show IP interface brief on here, I've got 10.0.0.1 for that link, which is here. I've got a loopback address, and I've also got my management network here. And while I'm here, I might as well configure gigabit 2. Now, I'm using 10.0.0.1, 10.0.0.2. So I can't use 10.0.0.3 or 10.0.0.4. So the next address I can use is 10.0.0.5. So this port will be 10.0.0.5, and duplicate that. And this one will be 10.0.0.6. Okay. So CSR1 interface GI2, IP address 10.0.0.5, 255.252, no shut. Interface loopback 0 IP. No, I've already done the loopback on that one. We're going to jump to CSR3 now. This is interface gigabit 2, which is this one here. IP address 10.0.0. This one is .6. And we might as well do interface loopback 0. IP address 3.3.3.3. So now I should be able to ping from here 10.0.0.5. Yep, so that's working. So now I'm on 3, I might as well configure gigabit 1. So we've used 1, 2, 5, 6. We can't use 7, 8, so these will be 9 and 10. And let's just put those around. So this one is going to be 10.0.0. Now these could be any addressing you need them to be. It's just literally a point-to-point layer 3 link between the devices. And this one will be 10.0.0.10. Okay. So I'm on CSR3, so conft interface gigabit 1, IP address 10.0.0.9, no shut. This is just an EVE-NG. We're running virtual devices. It's taken the config, it's fine. We're doing no shut. Oh, no, it's come up. And then we're going to jump to CSR5, that one here. EI1, 10. No shut. Interface loopback 0, IP address 5.5.5.5. So now I should be able to ping back to 10.0.0.9 from this one, which I can. So let's just move. Now, so we've used 9, 10. We can't use 11, 12. So we're going to do 13 and 14. So duplicate that one. And 13. And this one is 14. So I hope this gives you a good idea just to visualize how these things all come together. I know for me it was very frustrating just seeing a topology and then bang, here's some code running and it's just there. But gigabit 2, 10.0.0.13. Now if If you're watching this and you're either a bit confused or you're not sure what's going on, please do leave a comment. I'll be happy to answer any questions you have on this. And if you haven't already and you like this and you want to see more, then also please do subscribe to the channel. I do produce videos in a lot more depth on Ansible and Python and Nornir and all sorts of things, network automation. This is just a very simple setup on how we get this topology. IP address 5.5.5.5. Okay, and then CSR6 is gigabit interface 2, GI2, 10.0.0.14. No shut. Loopback 0, IP address 6.6. No, I didn't want the 255. 255. There we go. So I should better now ping between CSR6 and CSR5. 13. Yep, I can. Okay, 2 more links to go. So we've used 13 and 14. We can't use 15 or 16, so we use 17 and 18. That one is going to be 17. And this one is going to be 18. Now, like I also said, I'm running this topology literally on a Dell PC in the spare room, 16 gigs of RAM, and from here, lab details status, we can see how. So CPU is on about 80%, memory is on about 56%. So for a little PC sat on a shelf, this thing is doing okay. It can probably take another couple routers, but this topology is fine, just to get my head around things. So where were we? CSR6 and Gigabit 1. Gigabit 1 IP 10.0.0.17. No shut. Interface loopback 0. No, we've done the loopback already. Fine. And CSR4 now. Gigabit 1 IP. No shut. So now should be able to ping 10.0.0.17. Okay, so the interface didn't come up yet. There it goes. So the final link is the top two between 2 and 4. So I can't use 18, 19 or 20. So I can use 21 and 22. This one will be, I'll make this one 22. And this one will be 21. Okay, so let's just finish this config off. So CSR4, Gigabit 2, Gigabit 2, IP address 10.0.0.22. No shut. and CSR2 gigabit 2. Then .0.0.21. Okay, so should be able to ping 10.0.0.22 from here over to here. Ping 10. Yep, I can. So great. So to clarify now, I have given every OSPF, every router on here, a layer 3 link between each device. So I can ping between each device, but we cannot ping between the loopbacks. So my goal is, if I just add a bit more text on here, is to be able to ping between this device, so this loopback address. So I've got interface 1.1.1.1 and the interface over this side is 6.6.6.6. And the thing is, if I now go to CSR1, so if I ping 6.6.6, it won't work. Why? Because it doesn't know how to get there. So there is no route for show IP route. All it knows about is the directly connected networks locally to this device. So what we're going to do is set up OSPF, router OSPF 1 network. And I'm going to show you this command. Now, I'll show you what I did there. So I'll go back into the code editor here. So I'll make this a bit bigger. So this is my Visual Studio Code where I edit everything now. So this is the OSPF config. Now to keep things simple, we're going to do router OSPF 1. This is the process ID. And then we're going to say network 10.0.0.0 0.0.0.255. So this is one way of configuring OSPF. I'll go into other ways in the next video when we do the automation. But this way is turning on basically OSPF on any network interface that is in the 10.0.0/24 network. And as we can see, if I now do show IP OSPF interface brief, it says I've enabled OSPF on gigabit 1 and gigabit 2. But you will notice that it's not enabled it for the loopback interface. So I'll show you another way to enable OSPF. If we go on to interface loopback 0, I can say IP OSPF 1, area 0. That's another way of doing it. So I could have done that under each interface. And you can see now, so you can either use a network statement to run section OSPF. So what I could have also done is added in the network statement here. Another way to do it would be router OSPF 1 network 1.1.1.1 255.255.255. Where is it? The wildcard mask of all the zeros, area 0, and then interface loopback 0, no IP OSPF 1. I've taken it off the interface command And so that way, so run section router OSPF. So I've now got the network statement defining these two, or you could define it under the interface itself, doesn't really matter. But now I've enabled these two interfaces for OSPF. So what we're going to do is run around these two devices. So now if I do I'll paste in that router. Now you should start seeing neighbors coming up now. Haven't done the interface loopback 0 IP. That's 2.2.2.2. Okay, so now I can say show IP OSPF neighbor. Whoops, show IP OSPF neighbor. And you can see I've got a neighbor. So from 2, I've got a neighbor of 1. So we're just going to go around to all the routers now. Router OSPF 1. No, I've got it. Yeah. Network 3.3.3.3. No IP OSPF neighbor. Now 3 is now appearing a neighbor with 1. 4. That one's come up. Network 4.4.4.4. And when we go into the next video, I'll show the automation of how this can be done very quickly. Base GR, no. Just going to do this. Network, this one is 5. Area 0. And finally on router 6. Uh, 6.6.6. So let's just validate. We've got all our peerings up. So show IP OSPF neighbor on router 1. Now you might see a difference here. Neighbor ID 3333 and neighbor ID 192.168.1.2.221. Now that's because we didn't have the loopback address configured on 2 when we enabled OSPF, so it actually picked the next address to use as the router ID. So if we just go on to 2, clear IP OSPF star, clear IP OS 1, and process. Reset OSPF process, yes. That'll bounce the process on here. The neighbors will bounce. And still saying that. So let's have a look at the config on here. IP interface brief. So what we can do is bounce the process on here as well. What we can also do is router OSPF 1 router ID 2.2.2.2. Now it wants me to do that. So clear IPOs. What you can do is set the router ID. So from 2, I've got a neighbor to 1, and you can see I'm now getting a neighbor ID here. So what I'll do is go on to each one, router OSPF 1, router ID, that, and then let's do that on 4, which is that one, router OSPF 1, router ID 4.4.4. IP OSPF neighbor. Yeah, so I've now got a neighbor with 2 and 6. 3, I got show IP OSPF neighbor. 5, no IP OSPF neighbor. 3 and 6, show IP OSPF neighbor. Now you can see the inconsistencies that occur here now. So 6 is 223. So 6 is getting a neighbor to this one, CSR4. Run section router OSPF. Even though I set the router ID. That's now sorted itself out. Now we're getting 4 and 5. I'm getting 2 neighbors here, but that's not. This will sort itself out in a minute. Now I'm just demonstrating this, that the inconsistencies that you can get when configuring things manually, which is what a lot of people do. So they'll just configure away, type, and I've already got inconsistencies in the way that this network has been deployed. So when we do this in the next video, when we do it with Ansible, we can see we're going to deploy the configuration exactly as it should be on every device perfectly first time. So the big thing is, let's just make sure this works. Ping 6.6.6.6. Bang. So there we go. I can ping from router 1 the loopback address of CSR6, which is what we wanted to do. So show IP route 6.6.6 is via 10.0.0.6. So it's actually taking this path here, and we'll look into the. I'll do a video after the Ansible video, and we'll show you some OSPF path calculations and why it's going this way and not that way. So I'm going to bring this video to an end now. I hope it's been of value. If you enjoyed it, please do hit that subscribe button. I'm currently sat around 3,800 subscribers. I'm trying to hit 4,000 by the end of May, so that's my challenge. So if you could hit that subscribe button, I would really appreciate it. And I will see you in the next video, where we're going to do the whole thing all over again, but using Ansible. So thank you for watching, and I'll see you in the next one.